So welcome everyone to our 2020 Gluten-Free Education Day. Things certainly look quite a bit different this year. I know that I truly miss being all together with you all and eating tons of gluten-free food in the expo hall. But we're just so glad that we were all still able to gather virtually and that we're still going to be able to learn today from some of the world's greatest celiac disease and gluten-free diet experts. And please don't worry, we know that food is such a huge part of this event. We will still have some great giveaways throughout the day from gluten-free food manufacturers. And at the end of the day, everybody who participates will be getting a coupon from Dr. Shar USA. So we are still trying to include food, even though we all are not together indulging in croissants right now. So before we get into the talks, I want to start out by saying a huge thank you to Sandy Warness and the Global Autoimmune Institute for their support for today's event and for all of the contributions they have made over the last 7 years. Sandy's organizations make so much of our education possible, and I just want them to know how much we truly appreciate their partnership. Sandy is with us today, and she's going to be helping with all of the introductions of our amazing speakers. So I'm going to turn it over to her to say a few words before we get to our first session.
Hi, I'm so happy to be here, and I'm so glad you all are joining us. I can't see you, but welcome. We're thrilled to be here. We've been doing this for quite a few years now, and we look forward to the time when we can do it again in person. So I'm Sandra Boak-Warness. I'm Executive Director of the Walter and Jean Boak Global Autoimmune Institute. We partner with Children's and the Celiac Group on educational research and other projects. We provide funding for scientific research with major research institutions. We provide comprehensive information, excuse me, it's morning, on our website, which is autoimmuneinstitute.org. I hope you all will visit it and enjoy what we have to offer and give us any feedback and suggestions that come to your mind. So welcome. Now I have the pleasure.
Oh, one more thing really quickly. I just want to do some housekeeping things before we jump in.
All right.
So, as you all know, we have 4 great sessions today. Each of the sessions is going to run about 1 hour, including time for questions and answers. If you have questions along the way, please submit them in the question and answer fields, and our moderators will be sending them over to the panelists. We are expecting quite a few people to be joining today, so if we are not able to get to all of the questions during the session, we will still be having all of them answered, and we will be emailing them out along with recordings of each of the sessions to everybody either tomorrow or on Tuesday, as soon as we have all of that information collected. So even if we don't answer it live, we promise we will still get all of the questions answered. So now we are going to jump into our first session, which is about measuring gluten contamination in food. As most of you know, our celiac program led 2 studies last year that were published in the journal Gastroenterology and the Journal of Pediatric Gastroenterology and Nutrition. One looked at cross-contact with gluten in shared kitchen spaces, and the other at cross-contact in schools. Some of you may know them as the toaster studies. Over the last several months, we've had so many questions about how we measured gluten in the food. So we asked the leaders of the lab that we worked with to come and talk to us today about how they actually measure gluten in food. So we have Luke and Tom from Bia Diagnostics, and Sandy is going to take it away with introducing them.
Great, thanks, Vanessa. Okay, session 1 is 9:30. It's Contaminate This. So it's my pleasure to introduce Luke Emerson Mason. He's the laboratory manager at Bia Diagnostics. He has been working in analytical gluten testing for a decade, specializing in method development and validations. Luke oversees the daily running of the lab and testing of customer samples to the appropriate ISO 17025 standards. Additionally, he serves on the board of directors of the Vermont Biosciences Alliance, a nonprofit committed to furthering bioscience research in Vermont and around the world. In addition, the second speaker will be Thomas Grace. He's the CEO of Bia Diagnostics, one of the leading food allergen testing laboratories in North America. Mr. Grace was also the co-owner of Elution Technologies, a leading test kit manufacturer specializing in food allergens. Bia Diagnostics provides third-party allergen analysis for some of the largest food manufacturers in the world. In addition, Mr. Grace holds an adjunct professor position in the Department of Pharmacology at the University of Vermont Medical School. He has worked in various fields from cancer research at Dartmouth and the University of Vermont Medical Schools to developing cutting-edge methodologies in microarray and SPR technologies to the development of a unique method for determining the grain source of gluten contamination. So these guys are just amazing and wonderful, and we're so happy they're here with us today. Thank you so much for being here.
Thank you for inviting us. I'm Tom Grace with Bia Diagnostics, and I just want to give you a little bit of background on Bia. We do primarily allergen testing in our laboratory, but we also do GMO testing, species ID testing, hemp testing, and a variety of other work besides research and development of new methods. And we publish our research and peer-reviewed periodicals. But a little background on Bia, actually a little background on me. I was born in Ireland in the early 50s, and my younger sister was diagnosed with celiac disease in about 1955. Post-World War II, celiac disease became known primarily because during the war, World War II, there was a lack of wheat and bread in general communities, and children who were suffering celiac suddenly got better. Then after the war, children who were suffering with celiac disease and bread became available, they went into remission. Actually, they went into getting the disease full-blown again. And then they realized that wheat, rye, and barley were the cause of these diseases. And my sister was diagnosed when she was about 3 years old, and she became what is known as banana baby. So bananas were substituted for wheat, rye, and barley in foods. And I grew up with a lot of bananas in my family. So a little background also in gluten testing. Back in the late 80s, a man named John Scarrett developed an antibody specific for wheat and rye. And that was converted into a method called ELISA, enzyme-linked immunosorbent assay. So you could make a method and give it to different companies, and they could run that method using that antibody. And that was a standard until about 1999, when a guy named Mendez out of Spain developed another antibody which was more accurate at detecting rye, barley, and wheat. The Scarrett antibody did not detect barley very well. The Mendez method did, and that's how. That's the method that we're using today, actually, and it's a little bit more accurate. It does overestimate some barley a little bit, but it's still the standard that is used throughout the world for detecting gluten in foods. And I'm going to turn this over to Luke Emerson Mason. He's the laboratory director at Bia Diagnostics, and he'll be glad to fill you in on the procedures that we have for detecting gluten.
All right, thank you very much, Tom, and thanks to everyone for joining us for the analytical gluten testing portion of this presentation. So we're going to run through a basic overview, go over the theory, and then we'll take you into our lab and show you the actual process of testing some gluten-free bread for the presence of gluten. So let's say we have a slice of gluten-free bread that we want to test. Maybe it has a bit of gluten in it. That gluten isn't going to be evenly distributed, so we can't just break off a chunk of the bread and test that. We'll miss any gluten. So we have to homogenize the whole piece, which evenly distributes the gluten portion throughout. We then take an analytical test portion, about 1 gram of that sample, measure that into a test tube, and extract it with a reducing agent. When the bread is baked, the gluten can become trapped in what we call the food matrix through Maillard and other baking reactions that form disulfide bonds. So you need somewhat of a reducing dissociating agent to get that gluten out of the food you're testing. So it extracts in the solution for a period of time. and then we dilute it further, pipette some sample out of that, and pipette it into a very tiny test well. So it's a very, very tiny test tube coated in antibodies that we're blowing up here. So then you pipette a portion of your sample into this test tube. Here it is magnified much more. Obviously you can't see the antibodies, they're microscopic, but as Tom mentioned, they're specific to wheat, rye, and barley, and specifically to the toxic amino acid sequence that would trigger celiac disease in sensitive patients. So any gluten that was in this original sample that we captured in our subsequent sampling is now distributed evenly throughout this test well. Any of it that is recognized by the antibodies is then bound to their active sites. We then wash out any excess. Gluten, and then we add a conjugated antibody that is another set of antibodies with an enzyme bound to them that's going to increase the reaction time later and make the test sensitive enough for what we have to detect. So any gluten that's present on the initial antibodies then gets also recognized by the conjugate antibodies, forming an antibody-antigen-antibody sandwich, which is why this is referred to as a sandwich ELISA method. We then wash out any remaining conjugate and add a substrate. And if this enzyme is present, because it's bound to the antigen, it's bound to the antibody in the sandwich, the substrate will turn blue. Based on that color change and a set of standards, as the color goes up, we know the amount of gluten present goes up correspondingly. So we can actually create a standard curve with computer software and measure where a sample may fall on that curve and how many parts per million, if any, it may contain. So that's the general overview of the process with a little bit of the background science. Now we're going to take you into our active lab and actually show you the process happening.
Before you go, I would like to mention that the Irish word for food is Bia, B-I-A. That word is Gaelic or Irish for food, and Bia is actually the FDA of Ireland. But we hijacked that name because it's very appropriate to what we do here.
Absolutely. So right now we're in our chemistry lab. We don't do any of our actual gluten or allergen testing in here, but we do analysis such as heavy metal, terpene, pesticides, and mycotoxins for other customers in other areas of the food system. So now I'll take you across the hall to our immunology lab. All right. Thanks for joining us on this little tour. Again, this is a working lab, so please excuse anything that looks not pristine. Here we have our racks of food processors. We actually use Cuisinarts and coffee grinders, as I mentioned, to homogenize samples. They work very well, as long as you can homogenize them enough, as I'll show you with these slices of bread. So here we have a popular gluten-free product that, many of you at home, I'm sure, have tried. And as I mentioned, we're not going to test the whole loaf. That's too much sample, but we don't want to take just one little piece because we might miss a clump of gluten that's present. So what we're going to do is take about 100 grams and maybe 3 or 4 slices of bread in our food processor. Obviously working with clean hands and clean equipment and gloves. Now we have a nice, evenly distributed sample. Any clumps of gluten that were in any piece of that bread would now be spread evenly throughout that. So now we have to take our subsample of that for analysis. So So we'll move over here to our analytical balance. And we have a test tube that we're going to extract the sample in with a reducing extraction solution and release any trapped gluten that might be present. For this analysis, we're going to take a 1 gram sample size. And we can show you what that looks like here. So the bread's pretty light and fluffy, so it's going to look like a bigger sample than some other things. All right, 1 gram on the dot. So that's the amount of sample we're actually going to test from that loaf of bread. So it's not a whole lot, making it very important to homogenize a representative sample portion. Just to give you some idea of the amount of gluten it takes to hit that 20 ppm threshold, in a pound of otherwise gluten-free food or flour, it takes about 0.1 grams of wheat flour. So if you can get that, about that much wheat flour in a pound of otherwise gluten-free food will put you at that 20 ppm threshold that the FDA considers containing gluten. So as I mentioned, we'll be using our reducing cocktail solution to extract the gluten from the sample. We're going to add 10 mils to the 1 gram sample we have present. Now we're going to take this into the other part of our lab for further extraction and analysis. Homogenization is obviously very important. So we give it a good vortex to fully mix the sample. Then we're going to put it in a shaking water bath at 50 degrees Celsius for 40 minutes. So here we have a sample that's been sitting for those 40 minutes, and it actually gets a second step extraction with 80% ethanol. Ethanol is very good. After the bonds are broken down, they're trapping the food. Ethanol is very good at further extracting any gluten that's present, making it detectable to the antibodies in the test kit that we'll be using. So now it gets 30 milliliters of ethanol. Further mix the sample. And now we're going to shake it for 1 hour at room temperature. Oops. So obviously this is simulated. We're not going to shake the sample actually for an hour, but this is the process it goes through, further mixing it and extracting any of the gluten that was broken down by the first step of extraction. We then centrifuge the sample to get anything out of solution. We don't want fats, sugars and that sort of thing to interfere with the test. We only want the gluten proteins to be in solution. So once that's been centrifuged and settles out, we're going to take it over to our lab bench for the actual ELISA analysis. So for this portion, the sample is now quite a bit diluted. We took a gram of sample, we added 10 mils of extraction solution, and then we added a further 30 mils of ethanol. Now we're going to extract it or dilute it an extra 1 to 40, so we're going to be at a total 1 to 500 dilution. So you're really detecting very, very low levels of gluten in the test wells. 500 times lower than the 20 parts per million in your actual sample. So obviously if we have a lot of samples in a day, there's a lot of time spent processing, there's a lot of time spent weighing out the samples and extracting them, and then diluting them out for the final test. We're then going to use our test kit here. It's the gluten R7001 test kit that's kind of the that's pretty much the industry standard across the world. There are a few other test kits. As Tom mentioned, there are some other antibodies that have fallen out of favor. There are some other companies that have alternative antibodies, but this is a very well-recognized gluten test kit that is most likely the one being used on any food that you may be consuming.
And AOAC.
It's also AOAC approved, which is an association of analytical chemists that's a nonprofit that certifies tests to say they do what they claim to do. So it has been certified by an independent panel of scientists to work very well. It does come with its own standards. These are what you create the standard curve that you compare your sample to. So we're going to pipette 100 microliters of all our standards and our sample into these tiny test tube wells that are coated with the antibodies, as we showed you on the blackboard, all magnified. Obviously at much smaller scale. You can't see any of the reaction happening, which is why we rely on that enzyme on the conjugated antibody to react with the substrate and turn color.
While he's doing that, I was going to talk a little bit about what's going on with the chemistry here. So the antibody is specific for the analyte, which is in this case gluten, and the toxic part of the protein that creates celiac disease. Is one of the toxic elements. But what's unique about ELISA, which is this method, enzyme-linked immunosorbent assay, is you're able to see what you can't see, because it amplifies the signal or the event that you're trying to detect by huge orders of magnitude. We're able to detect like a single black grain of sand on a white beach. So that's how sensitive the method is. We're able to detect down to parts per billion the gluten that's present in this sample. And then because we dilute it out so much, that translates up to parts per million. So the sensitivity of the assay, as far as quantitative goes, is about 5 ppm, and the upper limit of quantitation is about 80 parts per million. But again, the reaction level is down at parts per billion, and that's what's a great tool for this methodology. Again, use the antibody and a conjugated enzyme, and the enzyme is going to turn over its substrate, the thing that it's going to react with, 1,000, 1,000,000 times. So now you can see what you couldn't see before.
Yeah, definitely an amazing technology for analytical testing. So now I've put our standards and our sample in our test tube, and I would incubate it, shaking at room temperature for 30 minutes, so that any gluten present in that solution can bind to the antibodies in the test well, as we showed you across the hall. Now we need to wash out any remaining solution, which we do with an automated plate washer, which is a very nice, although fairly simple instrument. That simply removes all the solution from the well, sprays it full of water and wash buffer, and just make sure the only thing left on those test wells is the gluten proteins bound chemically to the antibodies. This is going to be a standard process for any ELISA test, not just gluten, but any allergen or other analyte in the health system, human healthcare diagnostic testing. ELISA is a very common tool using different antibodies.
You can also relate it to the current pandemic. A lot of the antibody detection methods would be using this technique for detecting human antibodies, let's say, in serum.
So now the wells are completely empty. The only thing left on them is any gluten that may be present in the sample bound to the antibodies. So the kit also comes with the conjugated antibody. So that's what we're going to add now for the second step, so that we can create our antibody antigen antibody sandwich. So again, it ends up being a lot of pipetting in the day, but lab testing is not always the most glamorous thing. So thank you for bearing with us.
For the faint of heart.
So this now incubates for a further amount of time at room temperature shaping, so that the conjugated antibody can bound to any antigen that is present from the last step. This then gets washed out again, so the well becomes completely dry, which I won't put you through that demonstration a second time. But we then add the substrate, as Tom mentioned, so that any of the enzyme present on the sandwich, conjugated antibodies, will react. The enzyme turns over the substrate and turns it blue. So as you said, you can have parts per billion gluten present in the wells, and this will cause a reaction so you can visibly see that. After a period of time, you can see the reaction creates color in the well, as we've shown here. So now you can see the gradient from no gluten in our standards up to 80 parts per million gluten corresponding to a sample. And the sample itself we tested, which appears to have no gluten present, which is a good thing for gluten-free bread. So now we're going to read this with an absorbance plate reader, basically measuring how much color is present in the samples. And the software will generate the standard curve that we can compare our samples to. So again, a lot of hurry up and wait, but fortunately this is a relatively quick reading of the results, which is very nice. So here you can see we have raw optical density values that are just numbers going from 0 up to 1.15, and they create this standard curve of the samples, which you can then compare your samples to. So turning that into concentrations, our samples have 0.4, 0.3 parts per million, which is well below the 1 ppm limit of detection of the assay. So absolutely no detectable gluten in these samples. That's pretty much it. The whole process from homogenizing the sample, extracting it, and running the assay takes about 3 to 4 hours. You extract for one sample, right? You homogenize the sample, you extract it for initially 40 minutes in the water bath. You then add ethanol, give it an additional hour, shaping at room temperature, centrifuge it, make your final dilution, pipette it onto the plate, incubate for half an hour, wash that out, add your conjugated antibodies, give that an extra half an hour, wash that out, and add your substrate for about 10 minutes, and then stop and read the reaction. So that, in a nutshell, is the entire process of gluten testing, with a little bit of the background on the science and the history of celiac disease.
So I'll just step in a little bit. That's a simple process that we went through just now, but many times the matrices are very complicated. They might be, anything from lipstick to cardboard to probiotics, things with enzymes. All these things make it difficult for you to detect the gluten in that matrices. And foods can be processed in such a way they can be boiled, baked, fried, extruded. All these things create different chemistries within that food. And adding all these other compounds that are in there, polyphenols, tannins, etc., can also make it very difficult to extract out that protein that you're trying to find, that gluten that you're trying to find in that sample. So this process we just showed you is with one that we know works very well, but sometimes we have to do other things to the sample to ameliorate the extraction process. We might add another reagent there to block nonspecific binding. We might have to heat the sample to a very high temperature to neutralize certain enzymes or other compounds that we know that won't affect the gluten, but will affect those things that can interfere. So the process for extracting these type of matrices can be very complicated, and but we have worked out various ways of doing that in our laboratory, and we've actually somewhat blazed the trail in some of this extraction process and validated that here at Bia.
All right, and I think with that, we'll leave plenty of time to open it up to questions if anyone has submitted any or would like to.
Yes, we have lots of questions coming in here for you guys. So we are going to start with Alora, who's a 10-year-old child who submitted a question. How do you know which sample is which when you have a lot to test?
That's a very good question. So usually in a daily run, we'll actually label our samples with a unique code, a sticker for that day, and we write it on the top of the test tube and on all of our paperwork, and we put stickers on the sample itself. So we have a very well-defined system for uniquely identifying each sample with unique IDs.
And tracking it throughout. So each time we change the tube, every time we take the sample, put it into another tube, it's tracked throughout with that unique identifier. So everything is tracked from the beginning to the end, from the time the sample gets here till it's reported out to our customer.
Very good question.
But a very good, yes, exactly. That's one of the things that we had to work out here when we first started Bia. We started Bia 15 years ago, approximately, 14 years ago actually, and we had to work out that process of how to track these samples and make sure we didn't, cross-reference one other sample with somebody else's sample. Good question.
Great. Do all of the samples that you test usually have a tiny amount of gluten like the one you just showed?
Yes, I would say the majority have gluten below the limit of detection or quantification of the assay. And a lot of the ones that do have gluten is below 10 or 20 parts per million, so it can still be considered gluten-free.
Great. How many samples do you usually get in a week to test for gluten?
I would say, 250 to 500, depending on the week.
Wow.
And that's just gluten. We also do all of the other allergen analysis. So we could have many other samples for soy testing, milk testing, egg, peanut.
We have the largest portfolio of any laboratory for food allergen testing.
Great. So we actually have one question that sort of piggybacks on that. You mentioned that you can test for multiple foods. Can you run multiple tests like gluten and dairy on the same sample? How would that work?
We can, but each sample would have to get extracted differently. We could use the same homogenized sample, like when I ground up the piece of bread and put it in the Ziploc bag. We could take sample portions from that same sample, but each one would get extracted differently and would have to get run on a different set of test wells. Because these test tubes have the antibodies specific to gluten or to dairy. For example, if we do a milk test, they get extracted in a smaller tube with a different solution.
So here's a question. I'm on audio, not video, but so does your, from Blair, does your lab exclusively perform this testing, or does your company do other testing relating to other kinds of food as well?
Well, we do a variety of different types. We do hemp testing, GMO testing, species ID testing, etc. So it's not just per se food, but consumable products more likely is the way I would describe it. So if we're doing hemp testing, we're looking for CBD, how much CBD might be in something. Also, we might be looking at how much pesticide might be in there, mycotoxins, heavy metals. We do that all analysis here as well in the chemistry lab. So there are several laboratories that we have here that have different functions.
Oh, that's why your lab is one of the largest and I guess broadest really testing laboratories for allergies, right? And allergens and
yes.
Very, very impressive. Thank you.
So we have a question here from my mom. Hi, Mom. Glad you joined today. She says, you can blend a whole piece of bread. How do you test a piece of fried chicken or something larger?
Sorry, it's a very good question. So we would do our best to cut, the meat and the skin off the bone into a processor. We do our best to take representative samples. Let's say we have an entire roasted chicken, I don't know why we would be terribly worried about gluten in that, depending on how it was prepared, but we would try and take, pieces of the thigh, the wing, the breast, and homogenize those all together. So we get as representative a sample as possible. We do test a lot of gluten-free pizzas, so we do it, we try and get the crust, the pepperoni, the cheese, a couple slices from the pizza to really be representative.
And we test chicken and turkey here almost every week for gluten. So many companies want to label their product as gluten-free, and they'll send that sample to us. But they'll send us either slices of turkey or slices of chicken to do the analysis on that, and we homogenize it, process it, and run it.
We have another question, another good question. We have a question from Lisa Hardingy, and she asks about your customers. She says, who are your main customers? Businesses like UDI, private entities wanting to know gluten content, or cross-checking if companies are being accurate on their claims of a product being gluten-free?
Well, we get everybody that you can imagine sending us samples from around the world, from Canada, Mexico, as far away as South Africa. And some of the largest companies in the world send us samples, and some mom and pop operations send us samples. Some local companies send us samples. Beer companies send us samples. Nutraceutical companies send us samples for allergen testing, gluten testing, and occasionally individual people who are curious about, if their product, the thing that they just bought, does contain, they might have had a reaction, they're curious or not that it contained any gluten. We also work with gluten-free watchdog, Tricia Thompson, who sends us random samples probably weekly to do analysis on.
But primarily we do the analysis for food manufacturers before they release the product to you so they can be confident in their gluten-free claims.
We also work with the FDA on various projects. We just published something recently on a multiplex system where they've used antibodies that we've helped develop to detect a variety of different allergens, and we've worked with them and helped other organizations.
That is just so fantastic. Thank you for that answer. You can take it away, Vanessa, with the next one.
What do you mean by diluting the samples? Is the gluten diluted?
Yeah, so as we go through the process, let's say your 1 gram of bread has 20 parts per million of gluten in it. We're adding 40 mils of extraction buffer, so we're diluting that 20 parts per million 1 to 40. And then we're further diluting it, so it's at a final 1 to 500 dilution. So now we're 500 times lower than that 20 parts per million, which is, could use my calculator here to give you an accurate number. Yeah, which is 40 parts per billion, which is what as Tom was saying, what the test wells are actually detecting. So these are actually capable of detecting 40 parts per billion of gluten or lower. But we then back calculate that to what would be in the sample. So we account for the dilutions when we give you the results.
We multiply times 500
at the end.
If the dilution has been 500, sometimes samples might contain, let's say, greater than 80 parts per million, and we want to know exactly how much is in there. So we have to make extra serial dilutions to that sample, sometimes an extra 1 to 1,000, in order to get a value that's going to fall within the standard curve of our method.
I'm going to combine the next two questions from Omayama Kadir and Lisa Hardingy. They ask, will you recommend to the manufacturers or users which product has less gluten than others, and how does a user know which is safer? And in addition, how often are gluten-free companies expected to check and recheck their gluten-free status? Or really, do you see a general practice with regard to the frequency of testing products by manufacturers?
Yeah, so there are third-party companies like the GF label that you'll see on many products that actually tell manufacturers how often they have to test. And that's generally based on how risky an ingredient is. Like coconut sugar, for one, tends to oftentimes be contaminated with gluten. Which you wouldn't think of things like that. But certainly it falls into risk categories. We don't specifically tell customers how often they need to test. They have to develop that themselves based on their production schedule, but we can certainly consult with them and recommend things.
So yeah, all companies are required to, food manufacturers required to put out what they call a HACCP program, Hazard Analysis Critical Control Point program. And so they're supposed to go over and make sure that their manufacturing process does not produce any contaminants in the final product. So they must usually check their ingredients with a C of A, certificate of analysis, by their supplier. And if the supplier doesn't provide that with them, they might have to quarantine that ingredient before it's actually put into production. They should also, if it's a company that manufactures a variety of different types of foods, some gluten-free and some gluten not so free, they might have to make sure the equipment is clean, and they have to have a process for that. And really it depends upon their exposure to the consumer, that they really have to decide how much testing they need to do and when they need to test it. Some companies test only once a year. Some other companies test every single production line, beginning, middle, and end, depend upon what they feel their exposure level is for the consumer to possible cross-contamination. And they'll send all those samples to us. We'll either homogenize those three, beginning, middle, and end, and combine them to make one analysis, or we might do it individually, depend upon what the requirements are for that customer.
Wonderful, wonderful. We have a question from Sweet as Axe. She asks, are you able to test French fries cooked in a shared fryer?
Yeah, absolutely. We have certainly done that. Done quite a bit of research on that. We did it with someone, so it's not ours to share the results of, but certainly that is something that has been worked on and looked at.
And we feel pretty confident in what our results are.
Oh,
so we have another question that's come in that sort of relates to the French fry business. Is this test different than how Nemo would test foods in a restaurant, like French fries or soy sauce? I know that the Nemo test doesn't measure soy sauce. Are there any foods that you can't measure gluten in using this test that you use?
Right, so the Nemo test is also antibody-based. They use a different antibody, and it's on what's called the lateral flow test strip, which is similar to like a pregnancy test. You know, it gives you rapid results in a few minutes. It cannot detect gluten in soy sauce because it's been hydrolyzed, highly processed and broken down. This sandwich ELISA method also does not detect gluten in soy sauce or beer. But this company makes another gluten test called the competitive method. We would use to test things like soy sauce. So while the Nemo does not have that ability, if we get a sample like beer or soy sauce, we know to use the competitive test method that is accepted.
So would a user have to disclose to you that they thought there was soy sauce or beer in it, or would you automatically run both if you thought there might be?
We often ask our customer to provide us with any information pertinent to our testing. So whatever might be in there, we should actually know about. But anything that's new to the laboratory, as far as matrices go, we do what they call a spike recovery. We will add a known amount of allergen or gluten to that sample and make sure we get close to 100% recovery of what we put in there. So if we put in 20 parts per million, we expect to see 20 parts per million when we do the analysis. So there is something in there that could interfere that will be flagged by that process. Getting back to the Nemo, as you can see, what we have to go through to do the analysis that we do, so we're eliminating all the matrices, the contaminants that might be in there that could interfere. With the Nemo method, it's what I call is a down and dirty method. I mean, we've developed those similar methods here. And it can be accurate for certain types of foods as long as it's been validated for that food. But because, as I mentioned earlier, foods contain all these other things that could be in there, you could get a false negative or a false positive from that method more readily than you would with, let's say, the method that we're using here with the ELISA. Nemo, I think, is a good tool per se for screening, but again, you're probably much more subject to matrices interferences for that false positive, false negative rate, as opposed to what we see here.
Great.
Good to know, good to know. Susan Garthwaite asks, do you test liquids differently from solid foods?
Generally not, no. Again, like Tom was saying, if a solid food contains high levels of polyphenols, tannins, or enzymes, we may have to add certain blocking reagents to the extraction, but liquids are generally pretty straightforward. Again, if it's a beer or a soy sauce, we'll use the competitive method.
So if it's been hydrolyzed in some form, in other words, it's been fermented in some way, then yes, we would have to use a slightly different method that would be the competitive assay as opposed to the sandwich assay. Both of them are using the same antibody, but the process is different for doing the analysis.
Mm-hmm. We have a question from Sophia Ole. If everything you test, oh, pardon me, if everything you test is a small amount of gluten,
is it always a small amount?
Well, actually, I'm not sure that this is the case. Because not necessarily, I think you've explained that not necessarily everything does have a small amount of gluten. But the question is, if what you test has a small amount of gluten, does that mean that every gluten-free food is cross-contaminated, even if only by a small amount?
No, I mean, some of them certainly are, but it doesn't necessarily mean that.
I think the majority of it is not. I think the majority of the samples that we test here do not contain even trace amounts of gluten that we can detect. Now, we don't go down to zero because there is no zero. We can't, go down to parts per trillion or parts per trillion to detect, something that's there, because it's not etologically active. I mean, you're not going to have a reaction with, less than 1 part per million of gluten in your food. So the threshold level for the method is for quantitatively is about 5 ppm. For qualitatively, in other words, how low can it actually detect with relative consistency, is about 1 ppm. But most of the samples that we test are below that.
Great. So another question that sort of goes along with what you just talked about, the test that you just ran got 0.4 ppm. How come the study that we saw, they listed the lowest amount as less than 5 parts per million? Can you report lower than 5 parts per million?
So as Tom was saying, the limit of quantification is 5 parts per million. That's statistically the lowest level you can accurately quantitate. Yes, the test can detect between 1 and 5, below 5 down to 1, and it will give you a number, but that number is not statistically accurate. It's not repeatable.
So it'll tell you a number, and it might be something there, but it's not something that you can say you can test over and over again and get the same number. We could test it 5 times and get 1 ppm, 1.5 ppm, 2 ppm, 2.5 ppm, 0.5 ppm, and that's almost noise. So distinguish between the noise of the method and what actually can be detected and reported is 5 ppm, and between that, those two numbers, 0 and quote unquote 0 and 5, we say 1 is a number that we think that has some sort of statistical significance, but not reproducible. If that makes sense.
So we report our results out as less than 5 is the lowest we go.
Got it. From Adriana, do you take multiple samples from the same product to double check your results?
If we get a presumptive positive sample, yes, we take further subsamples to confirm our results.
So when we take the initial sample, we're taking multiple samples from that sample to do the analysis. So we might take 3 or 4 or 5 slices of bread, 3 slices of bread, to do the analysis on that sample. Even though there might be 15 slices of bread in that, we're only taking 3, somewhere at the beginning, maybe in the middle, maybe at the end of that bread, to make sure we don't miss anything. We can't homogenize the entire sample. First of all, then we can't go back and recheck it easily if there is something happens in between. So we always leave a little bit, hopefully, so that we can go back and test. But generally speaking, we take multiple samples to do the analysis of that, to make that one sample. Does that make sense? Multiple aliquots.
Yeah.
Alexis would like to say, this is not a question, but thank you for showing us how this is done. This was so interesting.
Oh, you're welcome.
So carrying on with the same sentiment, this was so fascinating. We want to thank you so much, Luke and Tom, for showing us through the lab, for answering all of our questions, and for really helping us all better understand how to measure gluten in food. So
You're very welcome.
Taking your time today. To all of our participants, It is now time for our first break. We want you to stretch your legs, get a snack, use the bathroom, and then come on back to join us at 11 a.m., where you're going to hear from researchers who are working on developing drug treatments for celiac disease and what you can expect in the future. You definitely do not want to miss this session. So we are going to turn off for just a little bit of time here, and we'll see you all back in just a few minutes.
I want to acknowledge Adam for being our cameraman in this process.
Yes.
Thank you all for listening.